Hello everybody, this is a video that is going to go over the chi-square independent practice that was posted on the week 8 Canvas module. This follows with the chi-square guided practice, which I walked you through in a previous video. So this is more practice with chi-square, which, because there's so many moving parts to chi-square, is appropriate that you're getting more repetitions. I'm going to go ahead and read this fact pattern to you, and then we're going to go through the steps of working through chi-square. The first thing I'm going to do is read this fact pattern. A social worker would like to understand if any association exists between smoking and anxiety. To set up this study, he asks respondents whether they smoke and whether they experience symptoms from a list of those associated with anxiety. The results are as follows. Of those who identified as smoker, 12 declared they have experienced symptoms of anxiety, while 8 did not. Of those who identified as non-smoker, 7 stated they experienced anxiety, while 13 did not. The first step for a fact pattern after you read it is to come up with a formulation of the null hypothesis. As you recall, the null hypothesis meaning no, null meaning no, all of the null hypotheses are going to begin about the same. There is no, I'll even be emphatic about it, there is no, okay? In this particular case, I can say association or relationship, so I'll say association, okay? And actually, I'm going to try to turn this off, okay? There's no association between, oops, how about we go like this? Between smoking and symptoms of anxiety. Okay, so there would be your null hypothesis. The next step would be to go straight into creating the observed values cross-tabulation. Notice that the first thing I do is have a cross-tabulation with observed values in the top left-hand cell. That's a real easy way to just remind yourself that you're putting in the observed values and not confuse them with the expected. Now, as you know, there was 2 main variables here. One was smoking, and I'll put that on the left side here. I'll call it smoker. Let's just do it like this, smoker. And we'll say non-smoker. Okay, and the other variable here is going to be anxiety. So we'll say anxiety, okay. So whether or not a person met the criteria for having anxiety or non-anxiety. Okay. As you know, the final column and row for these are the totals. Okay. And you know that this is going to ultimately be where the n sits. Okay, because the values of the rows and the columns, okay, or rather the columns are going to total up here and the rows are going to total up here. But we're going to go ahead and fill in the values for the observed values right now. So let's go up here where we saw smoker. Okay, the smoker category where anxiety was experienced. Okay, there was 12 individuals who stated they were smokers and experienced symptoms of anxiety. Okay, of the smoker category, 8 did not, for a total of 20. Okay, now we'll go down to non-smoker. Okay, non-smoking. Okay, for the non-smoker category, 7 experienced anxiety, whereas 13 did not. Okay, and again, we have an even 20 there. When we go down in terms of totaling up everything, 8 plus 13 is going to give us 21, and 12 plus 7 is going to give us 19. So together, okay, n equals 40. So now what we've done so far very easily is we have created, after reading the fact pattern, a null hypothesis and the observed values cross-tabulation. The next step will be to create the cross-tabulation with the expected values. For this segment, we're going to fill out the expected values cross-tabulation. You can see above the work we did previously with the observed values. These were all the values we found from our fact pattern as they were given to us. So that should look familiar. As you'll recall from the guided practice, the way to fill out an expected values cross tabulation is to begin by putting in the borders. Putting in the borders including the categories with the attributes of the variables and the totals. So we have the outside and we're going to build in. Now the way to do this, of course, is for any cell, let's just start with the smoker/anxiety cell, this one right here. The way to do this is to look at the ends. What I mean is the ends of the rows and columns. So we'll say 19 right here. We'll just jump right into it. Okay. So we'll say 19 times, and then what's the other end? Okay, 20. Okay. Equals. Okay. And if you need to, of course, I'm just going to invite you to just be absolutely sure and say 19 times 20 equals, okay, 380. We'll just knock that down to the toolbar, and then the next thing we need to do is take that 380 and divide it by our n value, which in this case is 40. So we'll just go 40 there, and then when we go ahead and divide the 380 by 40, we get a very workable number. In this case, it's 9.5, 9.5, okay? 9.5, and I'm going to go ahead and just highlight that for you. Okay, again, what we're building right now is the table of expected values, okay, on our chart. For this cell, this is the smoker non-anxiety cell, and we're working to get the expected value here. And the way we do that, we look to the ends. 21 times 20, it's like battleships, okay, equals, okay, well, if we go to our very accessible calculator, we'll just say 21 times 20. What are we going to get for that? Okay, 420. Okay, we'll just say 420, go down one, 420. We'll divide it by n, which again is 40. Okay, we'll come down here and easily divide by 40, and you'll see what we have instantly, 10.5, another very workable number. Okay, 10.5, which I'll create for you in boldface, okay? There you are for boldface, okay? And here's the great news about this, okay? Take a look at this. This again, for this cell, non-smoker and anxiety, let's look at these numbers. 19 again times 20. Well, didn't we do that up here? We certainly did, so why repeat? Why repeat all the steps when we can just, as my daughter would say, hack? Well, just, we already know it's there. Why should we spend all that time doing the calculations when we already know what we're going to come up with? So I'm not even going to reach for the calculator here. I'm just going to go ahead and put that in because I already know what it is. Lo and behold, the same thing happens over here. We see that the number 21, okay, whoops, let me go ahead and just get that off. 21 times 20. And lo and behold, that is, again, exactly what we see in the above cell, the smoker non-anxiety cell. So all we have to do is just repeat the steps. We don't even actually have to do any calculations because the numbers are all the same. We're just basically, I'm just going through the long form of this to show you how we got it. But again, you don't really have to do any additional work here. So really, we only have to do the work for 2 of the values, and then the rest were just repeats. So again, I'm going to go ahead and show you what this looks like in its completed form. Okay, when I take out all the math, when I take out all the work we've done, okay, we can see what our expected values are. So here are all of our expected values. And now the next step is we're going to compare the observed values to the expected values, run our formula, and come up with the calculated value for this chi-square. Okay, and now what we're going to do is use our observed values and expected values to come up with the calculated chi-square value for this fact pattern. We're going to do so using our formula, which we went over in the guided practice, but we'll do so again here. You can see that we have chi-squared, and this is supposed to be the chi, this is the symbol for chi-squared. You can see that you have the sigma, which we're familiar with, basically asking us to take the sum of all of the values for each cell. And the way we're going to find the value for each cell is we're going to take for each cell the observed value, subtract from it the expected value, square the value, and then divide by the expected value again. So how's that look in real time? Let's start with this cell. I call it the A cell. You can call it whatever you want. Call it the first cell. So what we're going to do here is I'm going to go ahead and I'm going to say 12 minus, in this case, 9.5. Okay, and of course we're going to make sure that that is going to ultimately be squared. Okay, there you go. And we'll go off with that. Okay, so let's just start with that first before we divide it by, the expected value again. So we'll go here. Okay, and as usual, we'll go ahead and use our calculator. Clear it out. 12 minus 9.5 equals, okay, 2.5. Okay, so we'll go down here and we'll say 2.5, and again, that's got to be squared because we didn't lose that yet, did we? Okay, squared. Okay, and when we do that, okay, when we go ahead and find the squared value, okay, we'll go ahead and put that down there. So how do you do this on your calculator? Pretty easily. There's 2.5. There's the square key. Your calculator probably has something like it. Okay, 6.25. Okay, so we'll go here and we'll say 6.25 divided by, again, the expected value, 9.5. Okay, and this will give us what we're looking for that cell. Okay, so for that cell, we're going to go back up here and we're going to say 6.25 divided by, okay, 9.5, going to give us a total of 0.66, okay, because we're just rounding, 0.66 to the hundredths, okay? All right, make sure we just capture what we need. Okay, and we'll go to the next cell. Okay, the next cell, I call this the B cell. You can call it whatever you want. The corresponding cells of smoker and non-anxiety here, smoker and non-anxiety here for the expected value. So we'll go ahead and start with the observed value, which is 8 minus, I think I got the, okay, 8 minus 10.5, okay, and of course that's going to give us, okay, a number that is going to be squared, but we're going to make sure that we don't, at least we have this correct. Okay, so go ahead and take out your calculator just because we need to be extra sure. Okay, and we'll say, we already know it's going to be negative 8 minus 10.5 is going to give us, surprise, negative 2.5. So again, because we're doing equally to each one, we're going to square both, everything we're squaring up here, we're going to square in the next one down. It all gets squared, doesn't it? Okay. All right, so we're going to say, so we know the notations. All right. All right, so we already know what it's going to be, don't we? Because 2.5, whether it's negative or positive, is going to give us 6.25. Okay, but this time our expected value is not 9.5, it is 10.5. Okay, and what's this going to give us? Well, let's find out. Okay, so we're going to go clear this out, and we'll go ahead and say 6.25 divided by 10.5. Okay, and that'll give us, okay, 0.59, which is actually going to round us up to 0.60, isn't it? Yes, because that would be a 10. Move it on up. Okay, we're going to go ahead and go 0.60. Okay. All right. So let's go ahead and set this one up straight. Okay, coming down to the C. I call this the C. You can call it whatever you want. Okay, the observed value in this cell, which is the cell of non-smoker and non-anxiety. Okay, 13 right here. Come down to the corresponding one here. Again, subtract 10.5. Okay. Is it going to be squared? You know it is, but we just want to say it out loud so we know we said it. Okay, and when we do that, okay, what's this going to be? I already know the answer, but I'll walk through it with you real quickly. Okay, 13 minus 2.5 sorry, 13, sorry about that, 13, okay, minus 10.5, sorry about that, 10.5, whoops. All right, let's go with that. You knew that was going to be that, didn't you? You knew it was going to be 2.5, right? Okay, let's do that, 2.5, okay, squared. Okay. And we already know what it's going to be because we've done it a number of times already. And we also know it's going to be the same here because we just did it in the, we did the same denominator in the previous cell. Okay, you know it's going to be 0.60. Okay, no real surprise here. Okay, all right, and now for our final cell, I'm going to go to what I call the D cell, or okay, up here 7. Okay, minus 9.5. That's what we see down here. Okay. And squared again. Yeah, I think so. We got to be absolutely consistent here. That's what we have to do. Okay. Now, when we come here, we're going to see what. Okay, well, you already know, but we'll just go through it one more time just to be absolutely sure. We'll say 7 minus 9.5. Okay. Did you know what it was going to be? Boy, I think you did. Okay, we'll say negative 2.5. It's going to be squared. I guess I just like using the subscript up here so you can see what I'm doing. Okay. Plus, we want to be absolutely sure of what we're doing. 6.25 is what we're going to find here, divided by 9.5. Did we do that earlier already? I think we did. We did it right here. We did it right here. It was our first cell, the A cell. Okay. 0.66, okay, is going to be what we have here. Okay, we'll boldface that out. Okay, and I think what I did already for your viewing convenience is I went ahead and I put the calculated here. Okay, and how's the calculated going to look? Well, we're just taking all those numbers because remember what this formula tells us to do. It tells us to sum it all up. So 0.66 plus 0.60 plus 0.60 again plus 0.66 again. Okay. So when we get all these cleared up, okay, I'll just make them nice and clear for you. I always worry about whether or not people can see this stuff that well. It kind of sets it off from the addition marks. So the addition signs. Okay, so let's go ahead and move right down to our calculator, and we'll go ahead and sum it all up. Okay, and we'll do it this way. We'll go 0.66 plus 0.60 plus 0.60 plus 0.66. Did I do it all right? I hope so. 2.52. So the calculated value for us today for this chi-square when we compared, or when we calculated the observed and the expected is 2.52. Okay, and I don't know if you have a calculator like mine, but I think all PCs have this form. You can kind of just always double check to see you got the amounts right up here. Sometimes it takes away the 0 if it's not necessary. Okay, so now we've done it. We found the calculated value for our chi-squared. Now in the next segment, we're going to look for the critical value. So now we're going to move into finding the chi-squared critical value. As you know, we've already found the calculated value right there. We're going to need to do a couple of things in order to find the critical value. First thing you're going to need is your textbook. On page 69 has the chi-square critical values chart. I have a representation of that same thing here on my computer, and I will pull it up at the time we need it. In terms of finding the degrees of freedom, which is what we're going to look for to find the critical value, the formula we use for that is number of rows for our chi-square. Remember, they don't always have to have 2 and 2, but ours does. Okay, but look at this, number of rows, number of columns. Now, when they're talking about the number of rows and the number of columns, they are not including the titles and the totals. So we're not including the titles or the totals, okay? It's mainly just these 4 squares that we're concerned about. or these two columns, okay, and these two rows, okay? So what we're going to do here is we're going to simply say to ourselves, well, how many rows do we have here that meet those requirements? Well, we have, okay, this row with values and this row with values, okay, but we're not including the totals, okay? So we're going to say we have 2, okay, rows minus 1, okay, times, and the number of columns, okay? Well, we have this one, and we have this one. We're not doing the totals, we're not doing the titles. Okay, so we have 2 minus 1. Okay, again, if we subtract 1 from 2, we're going to get a 1. Okay, if we do that again, we're going to get the same number. Surprise, we're going to get a 1. Okay, so our degree of freedom for our particular chi-square today is a degree of freedom of 1. And so when we come to our chart, okay, we don't have to move our finger very far. We just say degrees of freedom, or on our chart in the book, it just simply says DF in lowercase italicized. And we move down only 1 spot, okay? Then to make sure that we're at the correct level of significance or confidence interval, we know that the APA for social sciences is going to set it at 0.05 as the default. So we know the degree of freedom is 1, and we just keep moving over till we find 0.05, and it happens to be 3.84. Okay, everyone see how I got that? Degree of freedom is 1. We move all the way over to 0.05, which is, in our particular case, the percentage we're looking for as a matter of default. Okay, so now we're going to come back to where we left off. Okay, come up here. Okay, we know that the chi-squared critical value is 3.84. Okay, so now we have one last thing to do, which is compare these values. Okay, and you can already see that one is smaller than the other, and now we're going to interpret what that means. So hang with me, and I'm going to set everything up so you can tell me and you can learn how to interpret the fact pattern when you have a critical value that's greater than a calculated value. Now we're at the final step. I have laid out for you what we already found in previous segments. Calculated value is 2.52. The critical value is 3.84. I reminded you here, when the calculated value is greater than the critical value, we reject the null hypothesis. When the critical value is greater than the calculated value, by contrast, we accept the null hypothesis. And then I said here, the critical value, and I put it down, 3.84, is greater than the calculated value, 2.52. Therefore, we shall accept the null hypothesis. And as you can see below, I've just reiterated the null hypothesis. There is no association between smoking and symptoms of anxiety. Now, you might be saying to yourself, well, gosh, it seems like that there is some kind of a relationship or association, but that's not what this data set says. That's not what this fact pattern says, according to chi-square analysis. So, maybe there are other studies done with more people and something else comes up differently. But for this fact pattern, we have accepted the null hypothesis because our numbers bore out a conclusion in which the calculated value was smaller than the critical value. And that's how you do this. I think this is just another example of how with statistics, you don't always get an outcome you expect. And then with samples, depending on the size and depending on the characteristics and makeup of your population and whether or not there were biases in your sample, you could have very different results. But for the hypothetical I gave you, this is the end result. Okay, hopefully that was fairly clear. We'll do more of these as we go along. So we'll just go ahead and leave it at that. And I hope this was something that you were able to get something from, and you can let me know if you're having any questions with this. Okay, thanks so much.